8, Unit 8, Lesson 1, Part 1, Introduction to Bivariate Statistics, Associations and Trends. In a traditional math problem, for example, if you were looking at how far someone can run in a certain amount of time, things tend to line up really nicely. Maybe you're going the same speed. The real world tends to be a bit more messy. For example, each one of these dots could represent a different person, running for a different amount of time, and going a different distance. Now, from what you've learned about slope, you could find out the speed of each one of these if you calculated the slope from the origin, assuming they started at 0, which they would. And each one of these slopes would give an average speed. So, you can find the fastest one by seeing which one's the steepest. The slowest one ends up being this first dot down here. But one thing for sure here is that as you spend more time walking or running, you do tend to cover more distance, pretty much no matter how fast. I can describe associations and trends in bivariate data, represented in a scatter plot diagram. So first, a little bit of vocabulary. Bivariate data is data from two variables where data is paired in ordered pairs, generally x, y. A scatter plot diagram is a graph in which bivariate data is displayed. So something kind of like this. We've got an x-axis and a y-axis. Remember that as things get further this direction, my value of x would increase. If this was 1, you'd have maybe 2 here, and 3, and so on. And as I get higher in this direction, I'd get bigger values for y. Scatterplot diagrams can display trends, also known as associations or correlations. So the two most common types, you've got your positive linear association. As x increases, y increases too. And you notice that the bigger values of x correspond with bigger values of y. And if you were to draw a line that tends to go close to most of these dots, it would have a positive slope. That's kind of why it's called positive association. A negative linear association, as x increases, y decreases. So for larger values of x, you get smaller values of y. And notice if you were to try to draw a line that goes close to most of the points, it would have a negative slope. Now there are 3 different types of no association. Excuse me. As x increases, y stays about the same. So the dots do tend to go close to a line. But that line is, it has 0 slope. And then in that second one here, you can see the dots tend to scatter all over the place. So as x gets bigger or smaller, y kind of it's all kind of random. Another thing that can happen is that you do have an association, but it is nonlinear. These dots line up in a nice circular pattern. The pattern does exist, but it's not a linear one. Okay, let's take a look at some examples here. So on this, we're going to determine whether this shows a positive correlation, a negative correlation, or no correlation, and then describe it. So on this one, you can see that computer sharing in Maria's school, that's probably the first thing you should read on a graph is its title. Look at the x-axis, it's years, and then students per computer, and it does appear to be going down. So this is a negative correlation. Okay, that's not what I wanted to have happen. So this is a negative correlation, and Let's describe it. So as x increases, x is the year. We wouldn't usually say as the year increases, we'd say as time goes by. The number of students per computer goes down at Maria's school. I probably ought to capitalize her name. Okay, and there's some reasons why that could be. It could be that there's getting to be fewer students, or more likely the case, because students tend to increase over time, in my experience, they are getting more computers. So here in 97, 37 students per computer. That's probably one computer per teacher. And maybe not all teachers had a computer. And then as we get down here, they've probably got some computer labs and stuff. And it'd be even lower than that now. Okay. Determine whether the graph shows a positive, well, okay, same instructions there. Here, reading mail order prescriptions. This is the year and number of prescriptions. This shows, it appears to be a positive correlation. Okay, let's further describe it. It looks like as x increases, but x is the year, as the year increases, well, as time goes by, the number of mail order prescriptions, prescriptions, right, tends to increase. And there's reasons for that. It's nice if you don't have to go to the pharmacy and pick it up. You can just have it delivered right to your door in the mail. Okay, on this one, okay, reading the title first, state elevations. The mean elevation, that would be the average elevation in the state. If you could take the state and shake it until everything evened out, that would be the mean elevation, the average elevation. The highest point, that's in Utah, that would be Kings Peak. It's just the mountain that reaches the highest above sea level. Okay, there is a little bit of a trend here. We don't have a whole lot of dots. Look like there's only 7 states. Be interesting to see what this looked like if they had all 50 states. But it does tend to increase. As the mean elevation goes up, the highest point goes up as well. Rather than typing it out, I'll just state it from here on out. So on this one, it's a positive correlation. As the mean elevation increases in a state, the highest point tends to increase as well. Okay, right here, calories burned during exercise, the time in minutes compared to calories. So it appears that it is going up. It's a positive correlation. As you spend more time exercising, you tend to burn more calories. Library fines. This seems to be all over the place. The number of books borrowed doesn't seem to correlate with the fines that you pay. What the correlation here that we probably should look at is the number of days late that it gets handed in and compare that to the library fines. There'd definitely be a correlation there. But here I'd say there's no correlation. When more books are borrowed, it doesn't necessarily mean fines increase or decrease. Weightlifting. We've got pounds, the weight in pounds, and the number of repetitions. So when you are lifting weights, a repetition, like on the bench press, if you can pick it up and down to your chest, back up, that's 1 rep. Down to your chest and back up again, that's 2. And if you can do that 5 times, that's 5 reps. And this is actually something they would use to do what's called maxing out. When you max out on the bench press, that's the maximum amount you can lift once. So they can take this pattern down here, and if this is one person on several different attempts, they probably max out around 120 to 130, because you can actually see they did 1 rep right here at 120. But the situation here is that it's a negative correlation. As you lift more weight, you are able to do it fewer times. You get fewer repetitions. Okay, evening newspapers. Across the x-axis, we've got the year number. Across the y-axis is the number of newspapers. And it does appear to be a negative correlation. So I would say, as time goes by, the number of newspapers tends to decrease. Okay, let's look at temperature versus rainfall. This is the average annual rainfall measured in inches and the average temperature measured in degrees Fahrenheit. On this one, it appears to be kind of all over the place. I don't see any positive or negative slope to this. So I would say this has no association, no correlation. As the average rainfall changes, the average temperature doesn't tend to go up or down. It's just random. Okay, a little bit more vocabulary about scatter plots. They can have outliers, clusters, and gaps. Okay, outliers are points that don't tend to follow the trend. Clusters are a close grouping of points, and gaps are a relative absence of points where you would expect points to be. So let's look at this example here. Okay, an outlier, you can see outliers existing. Well, there's this one here. That's definitely an outlier. It's a good example of an outlier. Now, as far as clustering goes, there appears to be some clustering right here. It's a close grouping of a bunch of points. And also, oh hey, I already had those labeled. Very nice. Let me get rid of that. And right here, there's a gap. Makes me wonder if I've got... Oh, anyway, that is an outlier. So, good examples of that. Maybe there's some clustering up here. Nope. So we're going to look at a couple of scatter plots that have gaps and clusters in them. Here you can see a scatter plot showing Old Faithful eruptions. This would be in Yosemite. No, not Yosemite, Yellowstone National Park. And on the x-axis, duration in minutes. That would be how long the geyser is erupting. And then the time until the next eruption. How long you had to wait for the next eruption to happen. Now I want you to notice this right here would be an outlier. It doesn't seem to follow the data. There's a cluster here and apparently a cluster over here. Even though there's some points here in the middle, there's not very many of them. I would call that a gap because there's a relative absence of points. It appears to have a little bit of a negative correlation. So the longer that the eruption lasts, the less time you end up having to wait for the next eruption. Okay. This looks like it's maybe a different, what would you call it? A different geyser. Same kind of thing though, you can see some clustering going on. Okay. On here we've got the GDP per capita. This is pretty much telling you how rich a country is per person. The life expectancy. And there's actually a third variable. This is actually trivariate. It's got the population, gives you the size of the dot. Actually, there's four. The fourth variable is the category of the region of the world. So the Americas would be yellow, and down through all these other colors. By the way, some things I notice here. There is a definite positive trend or correlation. Countries that are richer tend to live longer. Their citizens live longer. Some other things. It looks like sub-Saharan Africa has the lowest life expectancy and, on average, and the lowest per capita GDP. Now there's a few others here that you should be able to recognize based on their population. This large blue one would be India. This large red one would be China. And the United States has the highest GDP per capita of any country. So we are this yellow one here. But there's a few other things you might notice here. But in general, richer countries tend to have their citizens live longer. Okay, this is also 3 variables on the same graph. This is showing the life expectancy, how long we expect people to live, versus how much is spent on health care. This is in US dollars per year, per person per year. Now there is an outlier here, the United States. We do spend a lot per person on health care, and there's a lot of reasons for that. There's a little bit of a gap here in the middle. I would say that there's some clustering going on. One other thing to notice here, in the United States, doctor visits per year, 0 to 4. We don't go to the doctor very much. Somewhere like Japan, JP, they go to the doctor 12 or more times per year. And you know, these other ones too. So there's some interesting things here that could be discussed. All right, let's look at just a couple more here. This is all just an introduction to bivariate statistics. Okay, determine what association exists. This is definitely a positive association. It's not necessarily very high, it's kind of medium. High, medium, and low is how closely it follows a line. This follows the line pretty well. There's a couple that are a little ways away from the line, kind of almost outliers. Write a complete sentence describing the correlation. It looks like as students spend more time studying, they tend to get higher test scores. 3. Describe any outliers by naming the approximate order pair and describing why you think it's an outlier in this situation. This one right here is a bit away from the line. This student studied for 30 minutes and got a 95, which for the amount of study time is an abnormally high score, kind of making it an outlier. Now I would assume this study time would include all study time throughout the unit, including what was spent on doing homework and stuff. Any clustering, not really a whole lot as far as clustering goes. I mean, we have 3 people getting 100%, but they're not really close together necessarily. All right, same thing here. Describe the association. This one is, I'd say it's a positive association, but it's not a very strong one. It's kind of a low association. There's a lot of spread. As cereal bars have more sugar, they tend to have more calories. As far as outliers go, maybe this one actually has quite a bit of sugar for only having 90 calories. That's a bit of an outlier. There's a little bit of a gap here in the middle, but not really much of one. I'd say that this right here would be a cluster. We've got 3 different cereal bars at 110 calories, and they're all right around 14 grams of sugar. Okay, barometric pressure. Barometric pressure is essentially the pressure of the air on the environment. The barometric pressure affects the ease of breathing, the temperature at which water boils, the amount of flour needed in a recipe, the weather, and other things. This has a negative correlation. As you go up in elevation, the air pressure tends to go down. As far as there's really no gaps, clusters, outliers, it's just given us one measurement every 1,000 feet. Okay, weekly activities. The amount of time spent watching TV versus exercise. Now, oh look, TV hours are counting by 5, so getting quite a bit of TV time. Exercise hours are counting by 1. It appears, though, that as you spend more time watching TV, you tend to spend less time exercising. This one right here I would think of as being an outlier. This person only spends 15 hours watching TV, and exercises very little at only 2 hours. Most others that were at 15 hours on the TV would exercise 5 hours, and most others that were exercising for 2 hours would have spent about 25 to 30 hours on the TV. So this person must have some other thing going on that occupies their time. As far as clusters and gaps, there's not really much there. Okay, this is the end of the first section of the first lesson here on bivariate statistics. Stay tuned for this parts 2, and thank you for watching.